Heparin Calculations. In this video, we're going to take a look at heparin. So we're looking at one specific drug, but this drug comes in a variety of forms. So heparin is a potent anticoagulant that prevents clot formation. It is one of the top 10 medications most frequently involved in medication errors. So we want to be very, very careful as we do our calculations with heparin, as the fact that it is a very strong, potent drug. And there's also lots of different room for errors. The errors come into play because there are a lot of different forms of the medication. And some of these forms involve very large numbers. So there might be something like 10,000 units. And it's very easy to just drop a 0 or 2 or misread a number, and then our calculation is off. So we need to make sure that we pay special attention to our calculations and make sure that they are indeed correct. So heparin comes in a variety of forms. The first one that's listed here is a subcut injection. So heparin can be given as an injection. That injection is usually less than 1 milliliter. So we would use a TB syringe and we would round to 2 decimal places. So it's usually a very small amount because of how strong it is. Our second form is an IV. So if we're looking at an IV, this is going to be in milliliters per hour. We would not use drops per minute for heparin because of how strong the medication is. We want to use the IV pump that's going to control that rate as close to what we need it to be. So if I'm calculating milliliters per hour, we're going to round to 1 decimal place because that's how I can set the pump. Heparin can also be ordered based on weight. So it may be ordered in milligram per kilogram per hour, and I would need to convert that over to milliliters per hour to set in the pump. So it can be ordered based on weight. I would need the patient's weight in kilograms, and then I would need to make the order specific to our patient by multiplying by their weight. Our fourth form would be as a bolus. So this would be the same as an IV push med. So when we have a protocol that is given for heparin, it usually is ordered in the way that the patient needs to receive a bolus first, which is this IV push med. And then after they receive the bolus, then they'll start an IV in milliliters per hour. So we'll look at some problems where we have that combination of a bolus and an IV as well. So when we look at our different forms, here are those specifics that I kind of just talked through on the previous slide. So our subcut injection, we're going to use a TB syringe. It's calibrated to the hundredths, so I round my answer to the hundredths. So I'm rounding my answer to 2 decimal places. It's ordered in units and it's given in milliliters. Our IV in milliliters per hour is ordered in units per hour, but I can't set that on the IV pump, so I need to find milliliters per hour. And if our heparin is based on weight, we need to find the weight in kilograms, and we'll multiply the dosage by the weight to find the recommended dose for the patient. And then our heparin bolus can be ordered, and then our heparin drip. So let's take a look at a number of different examples where we're looking at different forms of heparin. So example 1, we have an order for heparin 8,000 units subcut. What's available is 10,000 units per ml. So right away you can see how this could be very easily calculated incorrectly by just dropping a 0 here or there, and that could throw off our dose completely. So be very careful as you work with the zeros here, as you work with each number. Also, notice that I've written out the word units. You never want to abbreviate units with just the letter U, although you'll see that different places, but we don't want to get in the habit of doing that. If I write 8,000 units and maybe I'm someone who writes very sloppily for that units, it could look like another 0 on the end, and then I'm really looking at 80,000 units. Then I get a big difference. So let's make sure that we're not using U as the abbreviation for units, but in fact that we are just writing it out. So I want to determine how many milliliters the nurse should administer. So this goes back to a basic dosing question. I'm going to take my order, which is 8,000 units. I'm going to put that over 1. And I can't give the patient units, but I can give the patient milliliters. So I want to use my dosage strength. That's in units per ml. I'm putting the units down below so that those will cancel and we'll get milliliters. But this was 10,000 units per 1 ml. So with the 10,000, definitely make sure you use the comma in there. That'll just help you out to make sure you have the right number. So our units cancel. I end up with milliliters, which is what we need. And we end up with 8,000 over 10,000, which gives me 0.8 milliliters. Okay, notice that we have this leading 0 in front of the decimal point. Make sure that you include that leading 0 so that that decimal point stands out and it doesn't look like 8 milliliters, because there's a big difference between 0.8 milliliters as a subcut injection and 8 milliliters. 8 milliliters, you would kill your patient. So you need to be very, very careful with these calculations. Example 2. Our order is to infuse 1,400 units per hour of heparin IV. What's available is heparin 40,000 units in 1,000 milliliters of D5W. What rate in milliliters per hour should be set on the infusion pump? Okay, again, so when I look at heparin here, you see units. Our values for units are always pretty large, but then when I actually go to do the calculation, our numbers get much smaller. So I just have to be very careful and make sure that I copy down exactly the number that's given as we work through with it. So our order here is that the patient needs to receive 1,400 units per hour. So that's the rate that they need to get. Just unfortunately, it's in the wrong units. I need it in milliliters per hour. So let's start with that rate, 1,400 units over 1 hour. And I want to convert that to milliliters per hour. So I already have the per hour part, but now I need to get from units, so I'll need units down below, to milliliters. And if I look at what's available, we have 40,000 units in 1,000 mLs. So I can get from units to milliliters, and this is going to be 40,000 units to 1,000 milliliters. So my units are going to cancel. I end up with mLs. So we have milliliters per hour. I'm going to multiply the numerators, divide by the denominator, and I end up with 35 milliliters per hour. If it didn't come out to be a whole number, then I would round to the tenths. Example 3. Our order is for 40,000 units heparin in 1 liter, 0.9% sodium chloride. So this 0.9% sodium chloride, that's just our normal saline, to infuse at 25 milliliters per hour. Calculate the hourly heparin dosage in units per hour. Okay, so this problem is a little bit backwards from what we're used to. Here I want to find units per hour, and we know milliliters per hour. So again, we have the rate, it's just in the wrong units. So I'm going to start with that rate, 25 milliliters per hour, and I want to convert to units per hour. So I have the per hour part. I just need to go from milliliters to units, and I'm going to do that using our strength, 40,000 units in 1 liter. So because this is liters, I need it to be milliliters. So I need to do one more step in between here. I need to go from milliliters to liters, and then I can go from liter to units. Okay, so milliliters to liters, that's just within the metric system. So 1 liter is 1,000 mLs. And so our milliliters would cancel, and liters and units. So if we plug in what we know about our strength, we have 1 liter per 40,000 units. So liters are going to cancel. We end up with units. So we have our units over hours. So now I just need to do my calculation. So 25 times 40,000 divided by 1,000 is going to give me 1,000 milliliters per hour. Okay, so when I do my calculation, I just want to start with the rate that I have and then convert that over to the rate that we need. Now I need to take a look at one last problem here. So our order is for heparin drip at 18 units per kilogram per hour. What's available is 25,000 units of heparin in 1,000 milliliters of D5W. The client weighs 67 kilograms. What rate will you set on the infusion pump? Okay, so if I look at the question, I'm looking for the rate on the infusion pump. So what I'm really looking for is milliliters per hour. So within the problem, we have a lot of information. I know what's available, 25,000 units of heparin in 1,000 milliliters. So I know that I have my dosage strength. If I look at my order, we have a rate, but our rate is a little bit confusing in this one because we have units per kilogram per hour. So I need to convert those units per kilogram per hour to milliliters per hour. So let's start to write it out here. 18 units per kilogram per hour. One thing that I notice is that we already have the per hour part. Okay, so I don't need to do anything with that. One other piece of information I have is that we know the patient's weight in kilograms. So if we make that our starting point in our dimensional analysis, and I multiply by the patient's weight of 67 kilograms, I can just put that over 1 because I don't have anything to compare it to. The kilograms would actually cancel out. So once I multiply by the patient's weight, and when I see that in my order, that should be kind of something that sticks out to you right away. If I can multiply by the patient's weight, then it makes it specific to that patient, and then it helps us to get to the units we need. So now I need to go from units per hour to milliliters per hour. So I need to convert units to milliliters. And the way to do that would be to use our dosage strength. So since I have units up top here, I'm going to put units down below here, and I'll put the milliliters up top. Because in our dosage strength, we know we have 25,000 units in 1,000 milliliters. So that's why I knew I needed milliliters up top, because I had that in the strength. So the units are going to cancel, and I'm left with milliliters. So we have our milliliters over our hours, so we have all the information that we need. So I'm going to multiply the numerators together, divide by the 25,000, and I end up with 48.2 milliliters per hour. Okay, so this one was ordered based on weight. If I can multiply by the patient's weight right away, then I can get to a rate. Then I can take that rate and convert it to what I need, which in this case was milliliters per hour.